Okay, so we're going to start part 1 of inverse trig functions. So we've talked about inverses a long time ago. Inverses means opposite. So first I'm going to sketch a sine curve. So hopefully you remember that a sine curve starts at 0, it goes up, comes back down, and it looks the same on the other side. It repeats every 360 degrees. Now, we're going to sketch a graph of the inverse trig function. So, what an inverse looks like. Back when we did inverses at the beginning of the year, inverses reflect over the line y equals x, which looks like that. That's our line of reflection. So, if I carefully draw a reflection of this line, you might want to pause it at this point because this can be a little tricky to draw. But that's what the inverse sine function is going to look like. So if you were to fold your paper along that dotted line, you see how everything should line up. This red line here lines up perfectly with the black line. So if I fold my paper this direction, it should line up perfectly. The problem with this red line is that it no longer passes the vertical line test. It's not a function anymore. So what we do with this is we just look at a part of it. We're actually going to cut the graph off. We're only going to use this section, and I'm going to darken it right here. So if I just use this section of the graph, this now passes the vertical line test. So we actually cut the graph off, and there's a chart down here that shows you the cutoff points for the graphs. Arcsine, and that's a symbol for an inverse. We'll talk about that in a minute. But the range, the cutoff points, is we're just going to go from negative pi over 2 to pi over 2. So I'm going to mark this, negative pi over 2 to pi over 2. Okay, so one symbol that we use to show an inverse is this word arc. Now, another thing that we've done before is we've used this little symbol y negative 1. That's an inverse symbol. On a trig function, they'll put it between the sine and the x. So that means an inverse, and then the arc also means an inverse. So both of those mean inverse. You'll see it both ways. So you want to make sure you understand what both of those mean inverses. Okay, now cosine, this one, the inverse graph, just takes the part that goes from 0 to pi. So again, if I kept this cosine graph going, it wouldn't pass the vertical line test, so we're just looking at that piece of the graph that would be a function. And that's also in the chart. That's the second one here. It tells us that our graph goes from 0 to pi. Now the domain is negative 1 to 1, just like the sine and cosine curve go between 1 and negative 1. Their domains are still going to be negative 1 to 1. Okay, last we have the arctangent graph. Now tangent normally has asymptotes at negative 90 and 90, and then your tangent graph curves in the middle. Everything is going to be opposite. So now our vertical asymptotes become horizontal asymptotes at negative 90, so negative pi over 2 to pi over 2. And the trig graph is still going to have the same shape. It's just going to go in between those two asymptotes. So in our chart here, you can see the range goes from negative pi over 2 to pi over 2. So we're actually going to be solving some inverse trig functions. One thing you're going to want handy is your unit circle. So you can use the one from your notes. If you don't have your notes, you can go to our website down here. This is where I get it from, embeddedmath.com. Or you can Google embedded math unit circle. It'll pop right up. There's a filled out version and a blank version. So you can print yourself another one if you can't find a unit circle. Okay, so you're going to want one of those unit circles out, so you might want to pause it and go get a unit circle so you can follow along. Okay, so let's look at example 1. We're going to find the inverse sine, or we can say the arc sine of -1/2. So what we're doing is we're going to find the angle that gives us this answer. This is our answer, -1/2. Now, if I look at my chart for sine, my answers have to be in this range, because then it wouldn't be a function if it's not in that range. So I'm looking for an answer between, and I'm going to write this down, between -1/2 and pi/2. So I'm going to go to my unit circle. Sine, remember, is the y. So I'm just looking between -pi/2 and pi/2. So I'm going to draw a graph here too. So -pi/2 is down here at the bottom. Pi/2 is up here at the top. So my answer should be either in the first or the fourth quadrant. So I'm going to look and see in the first and fourth quadrant where I have an answer where sine is equal to -1/2. So take a look at your unit circle. And I see that right here at 11 pi/6, sine is equal to -1/2. Now, 11 pi/6 is not how I'm going to want to write the answer, though, because that's not between -pi/2 and pi/2. I'm going to instead write it as a negative answer. 11 pi/6 is in the same spot as -pi/6, right? If I start at 0 and went down, that would be -pi/6. So I'm going to mark that on my paper here, -pi/6. That gives me an answer of -1/2 for sine, and it's in the range of values that we need it to be. So there's our first answer. Okay, so let's try number 2. We have the inverse sine of √3/2. So I'm going to look at my chart again. Sine, our answers are always going to be between -pi/2 and pi/2. So I'm just going to write that down again so I know. And I'm going to look at my unit circle. So I'm looking for an answer in the first or fourth quadrant where sine, which is the y, is √3/2. So I see right away at the top, sine is √3/2 at pi/3. And pi/3 is in between -pi/2 and pi/2, so I don't have to change it. So that's my final answer. Okay, number 3. We're finding the inverse sine of 2. So, looking at my unit circle, I do not see any values where the y is 2. In fact, on a unit circle, the biggest answer we can get is our radius, and the radius on a unit circle is always 1. So 2 does not exist, and you can use the symbol DNE for does not exist. Okay, let's try a couple more. So let's go to number 4. We're going to do a cosine this time. So the inverse cosine, now remember, I'm going to write this at the top. The other way of writing this would be the cosine with the little -1, but they mean the same thing. So both of those mean the inverse cosine of √2/2. So looking at that chart from the first page, cosine has answers between 0 and pi. So I'm going to write that down. So that's the first and second quadrant. I'm looking for where cosine is √2/2. And cosine is the x. So I'm going to pull up my unit circle. Looking at the first and second quadrant, cosine is my x value. It's equal to √2/2 right here at pi/4. So that would be my answer. Okay, number 5. We've got cosine again, inverse, so we're between 0 and pi. I'm looking for the angle that gives me a cosine value of -1. So I'm going to look in the first and second quadrant again. Cosine is my x value. It's -1 over here at pi. Okay, number 6, we have an arctangent this time. So looking at the chart on the first page, the tangent answers have to be between negative pi over 2 and pi over 2. So we're looking again in the first and fourth quadrants. Tangent also, we have to remember, is equal to sine over cosine. And we have an answer of 0. So we're looking for where, if we were to divide sine by cosine, we would get an answer of 0. So if I'm looking in the first and fourth quadrants, right here, if I divide sine by cosine, 0 over 1 gives me 0. So tangent is equal to 0 at 0 degrees. Okay, number 7, tangent inverse of negative 1. So I'm looking to see where sine over cosine equals negative 1. And I'm just looking in the first and fourth quadrant again. So if it's negative, it's got to be in the fourth quadrant. If I divide sine by cosine, negative root 2 over 2 divided by root 2 over 2, I get negative 1. So it's got to be 7 pi over 4. But I can't write it as 7 pi over 4. I'm going to write it instead as negative pi over 4, right? In the first quadrant, here we have pi over 4. Down in the fourth quadrant, it would be in the same spot, but that would be negative pi over 4. Okay, so those are definitely tricky. So if you feel like you want to go back and rewatch those and try those again, that would be a good choice to make at this point. We're going to do some calculator problems now. So you can also solve these on your calculator. Now, the ones that we did with the pies, those we would not want to use our calculator for because these are exact answers. We know the exact answer. You don't want a decimal if you can avoid it. Now, sometimes they're not going to be points on the unit circle, so you're going to need a decimal to write as your answer. So looking at number 8, right, that's not a number on the unit circle, negative 8.45. So we're going to use our calculator to do that. So with the 84, you're going to arc tangent. So we're going to do second tangent. You'll see the little negative 1 come up, right? That's our symbol for inverse. Now you want to make sure you're in radians. So check your mode, right? Your mode should be highlighted over radian right there. So tangent inverse, and then we're going to type in negative 8.45 and press enter. And you should get negative 1.453. And we're going to round to 3 places like normal. Okay, on the Inspire, you're going to go to a calculator page. And you're going to type in your Trig's function. So over here on the left, where it says Trig, you're going to type in Trig, and you'll see all of your inverses come up there too. So you're going to go to inverse tangent. Now I'm not in degree mode, so I'm going to want to change that. Probably because I'm in Scratchpad. Settings. So I'm going to switch it to radians. Yep, it switched it over. So I'm going to type in negative 8.45, press enter, and I got the same answer, negative 1.453. Okay, so let's try a couple more. Number 9, we have the inverse sine, so second sine of 0.2447. For this one, I get 0.247. And then the last one, we have arc cosine. So second cosine of 2. Now on this one, I got an error. So it says error domain at the top. So that just means this is not in our domain. Remember, in the unit circle, the radius is a 1. We can't have an answer of 2. There's no further, it can't go any further than 1. So for this one, does not exist. So even if your calculator says it can't do it, sometimes that's true. So this one does not exist. Okay, so that concludes our lesson. Again, make sure you go back and review anything that you struggled with. You can rewatch the video as many times as you want.